Hello seniors, today we're going to continue with the third part of electronic assignment number 7 in which we were studying the more rules about derivatives, right? If you remember from the previous videos, we have seen how to differentiate a function using the power rule, then we have seen the derivative of e to the power of x, and finally the derivative of natural logarithm of x. So for today, we're going to learn two new rules which imply the product and the quotient rules for differentiation, okay? So let's go down to that part right here, okay. So we're going to start with a short investigation in order to see what this is about. It says, the derivative of the product of two functions. For steps 1 through 4, let ux, function u, be equal to x to the fourth power, and vx, function v, equal to x to the power of 7. And f of x is the product of the two functions, right? So it says the function f can be written as f of x equals x to the power of n. Find n. So basically, if we're said that f of x is the product of the two functions, we can say that f of x is equal to ux, which is x to the power of 4, times vx, which is x to the power of 7, right? So times x to the power of 7. And if you remember products of exponents with the same base, this would be equal to x to the power of 11, right? So f of x is basically x to the power of 11. So the value of n would be the exponent, right, which is 11. So n equals 11. This would be the answer for part 1. Then it says, find f prime of x. If we already have the function f of x, we already know how to find its gradient function, right? F prime of x, using the power rule, would be 11 times x to the 10th power, right? So this is f prime of x. Then it says, find u prime and v prime of x. So we want to find the derivative of u, which is this function, and of v, which is this function. Okay, so u prime of x would be equal to 4x cubed, while v prime of x would be equal to 7x to the 6th power, right? So we have the two results. I'm going to leave it like that because I don't have enough space. Okay, and then it says, for step number 4, find u prime of x times v prime of x. So basically what we're going to do is we're going to multiply this two. So this would be equal to 28 times x to the power of 9, right? Okay, so then it says, if f prime of x, is f prime of x the same as u prime of x times v prime of x? So if we compare f prime of x, which we found in step number 2, and compare it to this one, which we found in step number 4, you'll see that they are different, right? Why are they different if f of x was the product of u times x, times v, sorry? No, they're not the same, right? So we're going to see why later on. Okay, so for step number 6, it says, using the three derivatives found in steps 2 and 3, fill in the blanks below to make a true mathematical statement. So how can we really obtain this, which is the real derivative of f? Okay, so pay attention what I'm going to do here. If I fill this, f prime of x equals x to the power of 4 times 7x to the 6th power times v prime of x, okay? You'll see why in a second. Plus, this is v of x, and we're going to multiply it by the derivative of u, so times 4x cubed. If we multiply and add this, what do we get as a result? We're going to get as a result, this would be, let me do this with a different color. This first term would be, this would be 7 times x to the 10th power plus, and this would be 4 times x to the 10th power. And if we add both of these terms, we're going to get the final result, which would be 11 times x to the power of 10. And 11 times x to the power of 10 is exactly the derivative we had in part 2, right? The real derivative of f of x. Okay, so then it says complete the conjecture. If f of x equals ux times vx, then f prime of x is equal to, what did we write here? This is ux, u of x, times the derivative of v, v prime of x. Let me write my v better to avoid confusion. So times v prime of x plus, and then we wrote here x to the power of 7, which is the original function for v, which is right here, v of x, so times v of x, times, and we multiplied it by the derivative of u, right, u prime of x. So u prime of x. So basically, this is the rule to find the derivative of a product between two functions, okay? So before going to number 8, we're going to read what we have here. It says, the derivative of the sum of two functions is the sum of the derivatives of the two functions. If f of x equals ux plus vx, then f prime of x equals u prime of x plus v prime of x. Okay, that's something we already know. Is a similar rule true for the product of the two functions? And we've seen that for the product, this does not apply, right? If we find the derivative of both independently and then we multiply both derivatives, we're not getting the same result that we got when we found f prime of x, right? So the product follows a different rule, which is the one we found here. So it says, the conjecture in the investigation is known as the product rule. Many proofs are straightforward, but the proof of this rule uses a creative step. You can research the proof and find an example of a clever step needed to complete the proof. I'm going to be posting a video which demonstrates how or where the product rule comes from, and you'll see what the book means when it says that it uses a creative step. I will post that demonstration, which you don't need to know, but in case you're curious to know, I'm going to put the link to the video later on in Google Classroom. Okay, finally for part 8 of the investigation, it says, use the function f of x equals 3x plus 1 times x squared minus 1 to reject or help confirm your conjecture found from step number 7. Okay, so we can call this function, we're going to call it f of x equals g of x. We can call, I'm going to use colors for this. I'm going to call this orange part, I'm going to call this g of x. And the green part, this function over here, I'm going to call it h of x, for example, right? So basically, f of x is equal to g of x times h of x. Okay, so I can, instead of doing the product rule, I can, in this case, do the distributive, right? And then reorganize the terms and then find the derivative. So we're going to try doing that first. So we're going to rewrite f of x is equal to, if I distribute, this would be equal to 3, let me write all of the steps just to avoid confusion. 3x plus 1 times x squared minus 1, okay? So now, if I do the distributive property, this would be equal to 3x cubed minus 3x plus x squared minus 1. And there's no need to reorganize this. I can find the derivative directly. So I'm going to find f prime of x, which would be equal to 9x squared minus 3 plus 2x, okay? If you want, you can take this term here and it'll be the same thing, right? So this would be the derivative of f of x. Now, let's see from the conjecture we found in step number 7, if by applying the product rule we get the same result. So basically, what the rule says is that if f of x is gx times h of x, let me write that here, and I'm going to do it here. If f of x is equal to g of x times h of x, then the derivative of f, which is f prime of x, would be equal to g of x times the derivative of h plus h of x times the derivative of g. It looks long, but it's not. So what we're going to do first is, we already have g of x, which is 3x plus 1. We already have h of x, which is x squared minus 1. But we want to find the derivatives of both, right? So I'm going to find g prime of x. G prime of x is equal to 3, right? The derivative of 3x is 3. The derivative of 0 is 1. So 3 is the derivative of g. And the derivative of h prime of x, is equal to 2x, right? 2x. The derivative of x squared is 2x. The derivative of negative 1 is 0. Okay, so once I have all of the elements I need for my formula, I will insert that here. So we're going to have f prime of x equals to g of x, which is 3x plus 1, times h prime of x, which is 2x, plus h of x, which is x squared plus 1, times g prime of x, which is 3 times 3. Okay, so if I expand this, we should get the result. I'm going to distribute this. This would be equal to 6x squared plus 2x plus 3x squared plus 3. No, sorry, this was a negative 1 here. This is x squared minus 1. Okay, so this becomes negative 3 here. There. Okay, so f prime of x, if I organize terms, will be equal to 6 plus 3. I can add this, and this would be 9x squared. Then plus 2x minus 3. And you see that this result is exactly the same as this result, right? Only these two elements are in different order, but it doesn't matter if we change the order. So the result is exactly the same, okay? So with this investigation, we can find, or we saw, the general rule in order to find the derivative of a product between two functions, okay? So that is what this class is about. Product and also the quotient rule, which we're going to see in a second. Okay, so it says, what happened here? There you go. Okay, I don't know what happened here. Ah, there you go. Okay, so it says product rule and quotient rule for derivatives. And it says, for functions like f of x equals x to the power of 4 times x to the power of 7, and f of x equals 3x plus 1 times x squared minus 1, which are the examples we just saw in the investigation, you can rewrite the function and use a power rule to take the derivative. That's true, which is what we actually did in the investigation. But for other functions, such as f of x equals 3x plus 1 times the natural logarithm of x, you would need a rule like the one developed in the conjecture to find the derivative, right? We cannot do the distributive of this and then differentiate using the power rule, because the power rule does not apply for this type of functions, right? So it says the following rules are used to find the derivative of the product or quotient of two functions. And here you have the two rules, right? As we saw, power rule, exponential rule, and logarithmic rule, we're going to see product rule and quotient rule. So it says, if f of x is u times v, then the derivative is u times v prime plus v times u prime, okay, which is exactly what we saw in the previous investigation. And then we have, so if we read this in words, we're going to read the product rule in words first. It says, the derivative of the product of two factors is the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. Okay, so this is how you read this formula over here. And then we have the quotient rule, which is if f of x equals u divided by b instead of multiplied by b, then the derivative follows this rule. It's v times u prime minus u times v prime divided by v squared, okay? So you're gonna see this, both of these formulas are actually in the formula booklet, but they're written in a slightly different way, but the idea is obviously the same. So let's read how to read the quotient rule. It says, the derivative of the quotient of two factors is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared, right? There, this by shouldn't be there, okay. But you understand the idea. So, as I said here, both formulas are in the formula booklet, but they are written in this way, okay? Let me show you that in the formula booklet for you to see. If you go to topic 6, which is calculus, you're going to see that here you have product rule and quotient rule, and both are written in this, looks like Chinese language, but it's not, okay? So the product rule, the quotient rule. And as I mentioned before, this one is the power rule, which we already saw. This is a derivative of e to the power of x and derivative of natural logarithm of x. So we have seen this derivative, this derivative, this derivative, and we are studying this too now, right? Okay, so if we go back, let me show you how to read this formula. This is how you have it in the formula booklet, but you see it's basically the same. If a function y, which is f of x, for example, is written as u times v, then the derivative of y with respect to x, if you see this notation, dy over dx, this is basically the same as saying y prime, okay? So just remember that. So this is like saying y prime equals u times dv over dx. If we're talking about v, we're going to write v prime, right? Plus v times du over dx. So this is the same as saying u prime, okay? So you see that it's the same thing, although the notation for derivative changes, okay? That's the only thing that changes. The rest is exactly the same, okay? So that's how you interpret the formula, or these two formulas in the formula booklet, right? For the quotient rule, it's u divided by v. So the y prime equals v times u prime minus u times v prime over v squared, okay? So I hope this is clear. I want to do, we have tons of exercises here, but I don't think we'll have time to cover them all. So let's do the first set of exercises at least for this video, and then we're going to do the rest in another video. So let's apply these two new rules to some examples. So we have part A. It says find the derivative of each function. So the first function is f of x, let me write that here, f of x equals 3x plus 1 times the natural logarithm of x. Okay, so in this case, we are forced to apply the product rule, right? Because we cannot do the distributive here and use a power rule because we cannot apply the power rule to this type of function, to natural logarithm of x, right? So as we did before, this is what we call ux, the first function, u of x, and this other function is what we call vx, right? So the product rule says the following. F prime of x is equal to, and if we use this formula, you'll remember it's u times v prime u times v prime plus v times u prime, right? V times u prime. Okay, so we need to find these elements, v prime and u prime. U prime, let me see, I'm going to do it here. U prime, or it's better if we write u of x, u prime of x. In this case, u prime of x would be equal to 3, right? The derivative of 3x plus 1 is 3. And the derivative of v prime of x, if it's natural logarithm of x, the derivative of natural logarithm of x, if you remember from last class, that's equal to, let me show you, here it is, natural logarithm of x, the derivative is 1 over x. Okay, so the derivative in this case is 1 divided by x. So once we have all of the elements, we can find the derivative of f. So f prime of x is equal to u, which is 3x plus 1, times v prime, which is 1 divided by x, plus v, which is natural logarithm of x, I'll write this using parentheses, times u prime, which is 3. Okay, so if we reorganize this, we're going to have that f prime of x is equal to 3x plus 1, all of this divided by x, plus 3 times natural logarithm of x, and this would be the result for this derivative. This is the derivative of f. Okay, I hope this is being clear enough for you people. Let's go to part B, exercise B. It says f of x equals this times this. I'm going to write that. F of x equals x to the 4th power plus 3x cubed plus 6 times 2x minus 1. In this particular case, okay, you might think about doing the distributive, right? But it might get a little bit too long because you're going to get 6 terms in total, right? 2x times all of those 3 elements and negative 1 times all of those 3 elements, right? So in this type of cases, you could actually pick if you want to expand this and do the normal derivative you have learned, or if you want to apply the product rule. Since this is our first class about this rule, I'm gonna apply product rule once again to solve this. Okay, so you'll see that this process gets a little bit. You can solve this mentally. You don't need to write all of this in order to find this. For example, if I want to find the derivative of f, which is what I want to do now, this would be f prime of x. If you know the rule, you know it's u as it is. So I'm going to copy this as it is, x 4th plus 3x cubed plus 6 times v prime, that's the derivative of v. The derivative of v in this case is 2, right? Plus v, the original function v, 2x minus 1, times the derivative of u, right? Which is, in this case, 4x cubed plus 9x squared, right? That's the derivative of this function. So once I have that written, it's just organizing these terms in order to get to a final result, right? So here I'm going to do distributive and see what happens. 2x to the 4th power plus 6x cubed plus 12. And then we have, well, this will become a little bit long. Plus 8. I think I'm going to need more space here. Plus 8x to the 4th power plus 18x cubed minus 4x cubed minus 9x squared. Okay, there you go. So now I need to simplify like terms For example, x to the power of 4 with x to the power of 4, this would be equal to 10x to the power of 4. Then x cubed with x cubed and x cubed, this would be 6 plus 18, that's 24 minus 4, 20. So this is plus 20 x cubed. Then we have x squared, there's only one x squared, which is 9 minus 9x squared. Then we have x, do we have x? No, we don't have x, so it's just plus 12, okay? Plus 12. So this will be the final result of the derivative of f in this case, okay? Okay, to finish this, we're gonna see the last two examples which imply quotient rule, right? Which is the other rule that we also learned today. Quotient rule, as you remember, is when you have a function divided by another function. So let's do the first one step by step to avoid confusion. Okay, so in the first, let me write the function first. F of x equals 5x plus 3 divided by x squared plus 1. Okay, so here we can identify the first function as being ux, and the second function would be v of x, right? So if we follow the rule says that f prime of x is equal to, here you have the formula booklet, it's v times u prime minus u times v prime over v squared. So I'm going to write that here. It's v times u prime minus u times v prime divided by v squared. Okay, so first of all, I want to find what is u prime of x. In this case, u prime of x is equal to 5, right? 5. And v prime of x, in this case, is equal to 2x. Okay, so now that I know all of the elements, I can find the derivative. We're going to write f prime of x equals v, which is x squared plus 1. You should always use parentheses to avoid a confusion later on. So v times u prime, which is 5, minus u, which is 5x plus 3, times v prime, which is 2x, divided by v squared. V squared is x squared plus 1 squared again. There you go. So we can expand this and reorganize terms to see what we get as a final answer. So this is equal to 5x squared plus 5 minus and parentheses 10x squared plus 6x divided by x squared plus 1 squared. So then if we keep on expanding this would be 5x squared plus 5 minus 10x squared minus 6x divided by x squared plus 1 squared. Finally, we can simplify like terms, and the final answer would be f prime of x equals negative 5x squared minus 6x plus 5 divided by x squared plus 1 squared. Okay, so this is the answer for part C. Finally, to finish this, we're gonna do part D, the last example, which says D is f of x equals x plus 2 divided by 2 times e to the power of x minus 3. Okay, e to the power of x now. E to the power of x. There you go. So if we follow the same rule, here we have the rule, okay? So I'm gonna copy this. This is the rule. So if we do this directly, we're gonna write this as, or actually I'm gonna show the steps to avoid confusion. U prime of x is equal to, in this case, 1, right? The derivative of x is 1, the derivative of 2 is 0. And the derivative of v is the derivative of 2 times e to the power of x. Remember, the derivative of e to the power of x is e to the power of x once again. So this is 2 e to the power of x, and the derivative of negative 3 is 0. So that's it. So f prime of x will be equal to v, which is 2 times e to the power of x minus 3 times u prime, which is 1, minus u, which is x plus 2, times v prime, which is 2 times e to the power of x, over, don't forget the denominator, v squared, so 2 times e to the power of x squared. Okay, if we reorganize this, we will have f prime of x equals, this is 2 times e to the power of x minus 3, and here we can do the distributive. This would be minus 2 times e to the power of x times x, or actually it's better to write 2x times e to the power of x plus 4 times e to the power of x times 4 to the power of e to the power of x divided by, this would be 4e to the power of 2x. Sorry, I did a mistake here because v, this should be v instead. Sorry, v is 2 times e to the power of x minus 3 squared. So we just leave it like that, 2 times e to the power of x minus 3 squared. Finally, we can distribute this negative, and we would have f prime of x equals 2 times e to the power of x minus 3 minus 2x times e to the power of x minus 4e to the power of x divided by 2e to the power of x minus 3 squared. And the last step would be to add like terms. So this would be equal to yes, we can add these two terms. Yes. So this would be f prime of x equals negative 3 minus 2x e to the power of x minus 2e to the power of x over 2e to the power of x minus 3 squared. And then there's nothing else we can do. So this would be the final result for this exercise. Okay, I hope this was clear enough, seniors. This is really application of formula, right? So if you really understand how to read these formulas, you shouldn't struggle much finding the derivative of a product or a quotient between two functions. So I hope this was clear. Please let me know if you have any doubts, and see you in the next live session.